All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for the session here. So just like a little quick recap about OneClass and what we're about. So what we're doing here at OneClass is that we are providing kind of online solutions for frequently asked questions in math and chemistry, and these levels range from basically the secondary level. So basically from grade 9 all the way up to the university and college level. So today what we're going to do is we're going to run through some series of math questions, and we're going to answer, I'm going to answer these questions with you as well. This next kind of hour, we're going to focus mainly on kind of grade 9 algebra, grade 9 geometry. So maybe pre-algebra, algebra, and some geometry questions. And then the next hour, we're going to do more so grade 11, grade 12. So some more so algebra 2 and pre-calculus questions. I started off, I ended the last video off with a calculus question. I'm going to revisit that question back probably in the next live stream at about 12 p.m. And I'll finish off that question. I'll start where I kind of left off for that question there. So a little bit about myself. Again, my name is Joey. I'm currently a secondary school educator in Ontario. My teachable subjects are chemistry and math. So I'm very, very familiar with this, the curriculum that kind of goes behind these subjects. So I'm very familiar with asking these questions and also answering these questions as well. So let's get started on today's problems here. Okay, so we have a perimeter. Our first question is asking us, what is the perimeter of a rhombus whose diagonals are 16 and 30? So I kind of like this answer here, because what they're doing is that they drew a diagram, and geometry is really, really good because when we're drawing a shape here is very, very good to visualize a geometric question or a geometry question here. So I'm asking for the perimeter of rhombus whose diagonals are 16 and 30. So like they drew it over there, you have kind of a rhombus type situation here. And then basically you have diagonals that go from each side here. They kind of go from each side here. And they all intersect at 90 degrees, right? So all these guys here are 90 degrees. So they all make right angles. And we know that our diagonals here are how they written as. They wrote kind of A here, B, C, and D, and this here is O. So diagonals A and C would equal 16. So between A to C, this would equal 16, and from B to D here, from B to D here would equal 30. So it's asking us, what is the perimeter of the shape? Like, what is the perimeter of the shape here? So if you remember here, the rhombus is a quadrilateral with 4 equal sides, right? And its diagonals intersect at an angle of 90 degrees, which means the diagonals are perpendicular. So that means that all these sides here are equal. B to C is equal, A to B, A to D, and C to D, right? So all these sides are equal, which means the perimeter here is simply just 4 times one of these, the length of these sides here. So in order for us to do that, again, how they did it here is they did perimeter of rhombus can be shown, and they use P times A plus B times C equals P times A times D and C and D, right? You can say it's that, but we know that because A and B and C and A and D and C and D are equal, you can simply just say it's basically 4 times the amount, right? So it's P basically L plus W, kind of the same thing as a perimeter of a rectangle, right? Perimeter of a rectangle would be the 2 times 2 and then length times length plus width, sorry. So it's kind of very, very similar to this as well. So I'm going to write down the perimeter of a rhombus here. Equals 2 times, I can say length plus W. In this case, they wrote A plus B plus C plus D here. Or it could also basically AD plus CD, right? It's depending on which sides we know, but we all know that all of these sides are equal. So it's saying here, if diagonals A and C and B and D are known and they're given to us, the half of diagonals, so from A to O and from O to C here, would be simply just these numbers divided by 2, right? So what we know about this is that we know that every time we take a diagonal, if we take half the diagonal here, we know that it's from the one of the corners to one of the centers, or basically the center of our rhombus here. So if we know that from between A to C here, so let me do some blue. Between A to C here, we know that this here is 16. So 16 divided by 2 is obviously 8, right? So A to O would be 8 here, and O to C would be 8 here, right? So that's that. And then from B to D, the entire length here is 30, right? Entire length here is 30. So if we divide it by 2, then we would have 15 on one side and 15 on the other side, right? So this here would be the sides of the rhombus here. And we know that, remember, we know that these all make right triangles here, right? So these guys all make right triangles. So they basically, what we have here is we have simply just a right triangle, right? We have a triangle here with 8 on this side and 15 on this side here. And I'm highlighting, and I'm basically redrawing out kind of this triangle here. It has a side length of 8 and a side length of 15. And it's asking us what is the side length here? So what is this guy here? So in order for me to do this, again, I can easily do Pythagorean theorem to figure this side length out, right? So I know that x squared equals basically 8 squared plus 45 squared, and then, or sorry, 15 squared. I don't know what, 45, 15 squared here. And then x squared here equals 8 squared has 64. 15 squared would be, I believe it's 225. Double check that. 225. I add those numbers up together. 225 plus 64, and I would get 289. And I can square root both sides to get, if I square root both sides here, I would get 17 here. So my side length I know is 17. So this A to D here is 17, right? 17 here, which means my side lengths, because they're equal to each other, these guys are all 17 here, right? So now I can easily find the perimeter of my rhombus, right? I can say that 2 here, this here equals 2. This here equals 2. And the AD here is obviously 17. CD is also 17 here. So this is 2 times 17 plus 17 equals 34. And then finally 2 times 34 here is 68. So the perimeter of my rhombus here is 68 units. Yes, it's 68 units because they didn't give us our length here. So this solution here is correct. Again, hence the perimeter is 68. They did add probably something that's different than I did, because they substituted something different instead of the perimeter of the rhombus here. I just used the initial perimeter formula here, but they did 4 times the Pythagorean theorem. So basically they substituted kind of this formula here for AB here. So that works as well. It depends on how you think of the question. I thought of it as a right triangle, so I had Pythagorean theorem to solve for this, and then I substituted the number in. You can always do algebra first and rearrange for your unknowns, and then substitute it. So that works as well. Am I the only one watching? I don't know, actually. I can't tell how many. It doesn't tell me how many viewers are watching, so maybe you are, maybe you aren't. But again, thank you so much for watching. Yeah, so hence the perimeter is 68 degrees. So this solution here is correct. All right, that's number 1. Number 2 is asking a very easy question. It's asking us what is 35% of 60? It's asking us 35% of 60. So all we have to do is, if we want to convert, every time we see a percentage here, we want to convert this basically to a fraction or to a decimal, right? So if we're looking here, we have a percentage. You either want to convert into a fraction or decimal. So in this case, I would probably convert this into a fraction just so we can kind of manually calculate it. So if I have 35% here, I'm going to convert this into a fraction. So I know that this here, 100% here, is I'm going to divide it by 100%, right? I have if I want to convert this into a fraction, right? So this 35% in fraction is obviously 35 over 100, and I can always reduce this to lowest terms, but in this case it's not needed because it's not my final answer here. So 35% as a fraction is obviously 35 over 100. Again, percentages is always just a number divided by 100. And then simply you're going to take 35 over 100 multiplied by 60, right? I can say, right, 60 over 1 here, or multiplied by 60. I can cancel out these terms here. So I have a 10 here and a 6. I can cancel this again to a 5 and a 3 here, right? And then this would be I'm dividing both sides by 10 here. So I get 10 and 6, and then I get 5 and 3, yes. So then I have, so now I have, let's see, 35 times 3 here would be 105 divided by 5 here, which equals 21. So this here is our answer here, which means 35% of 60 here equals 21. So 35 times 3 was this is a 3 here. 30 times 3 is 105, and then 5 times 1 is 5, and then I simply just divided both of these numbers. 105 divided by 5 here is 21. So this solution here is correct. The answer, 35% of 60, is 21. All right, number 3 is asking, write an expression that computes the average of the values of 12 and 40 here. So I want an expression that computes the average of the values 12 and 40. So if I'm talking about the expression that computes the average from values from 12 and 40, what I have to do is I have to actually think about what is the definition of an average. So I have here an average is simply just equals to basically the sum of all your numbers here. So sum of you can think of this as your as a constant value. So in this case, we have two numbers here. We have 12 and 40, right? So in this case, we can write this as maybe like an x term, and this here is a y term. Or actually, maybe to kind of be in line with the solution, we're going to say this here is the a term, and this here is the b term. So you can say it's the sum of all terms here. So let's say it's a plus b plus c, and then so on and so forth, divided by the number of terms that we have on the top. So I'm going to define this as n here. So if I have two terms, this here n would be equal 2. If I have three terms, it would equal 3, and so on and so forth. So this here is how you calculate your average, right? So it depends on how many terms we have. In this case, we only have two terms. We have a plus b here divided by, and we have two terms here, we're divided by 2, right? So this here will be our expression that calculates the average, right? The average would equal a plus b divided by 2, right? And this here is the definition of, this here is our expression to compute the average. And obviously we can use this to actually find out what our average is. A plus b is 12 plus 40 divided by 2. 12 plus 40 here is 52 divided by 2, which would equal 26. So this here is the correct answer. As you can see, they wrote, it's a plus b divided by 2, which is great. And then they found the average here. They add the numbers and divide the number by 2. So it's 52 divided by 2, which is 26 here. So solution here is correct. All right, number 4 is that I just have kind of an expression here. So let me just write this down for you. So 15 times 1.5 minus 0.2 times 30.1 plus 60, or no, plus, I might have to make this smaller actually. So 15 1.5 minus 0.2 times 30.1 plus 0.0625 divided by 0.625 equals something. So we have this kind of long equation here. And what we're going to do is we're going to solve this problem, right? And we solve from left to right, but however, you have to remember bed mass and pad mass. So that states that we have to do a certain order of operations, right? We care about our order of operations here. So we care about this concept of bed mass, or if you're in the States, pad mass, doesn't really matter. It just simply states that it's brackets first. So let me write this down. So it's brackets first, and then it's exponents, and then division and multiplication are in the same category. And then finally, it's addition and subtraction are also in the same category. So if you look at our problem here, we don't have any brackets here, nor we don't have any exponents. So what we're going to do is we're going to do division and multiplication first. So this is 1. So this here is the first one, second one. These two are third, and these two are fourth. So as you can see, I see multiplication division first. So I'm going to do this step first, and then I have this step again. This is also multiplication, and then I have some sort of division here, right? So these three I'm going to have to do first before I do my addition and subtraction. So let's do this here. 15 times 1.5 would give me, let's see, 15 times 1.5 would give me 45 over 2, or 22.5. So 22.5. We keep my minus 2 here. And I'm going to do basically, this here is 0.2 times 30.1, right? So 0.2 times 30.1 here would give me a value of 6.02. So this is minus. So this here was 22.5. This here is 6.02. So negative 6.2. And then I'm going to add whatever the division between these two numbers are. So this is 0.0625 divided by 0.625. Again, we know that this here is 0.1 because this here, these two numbers differ by simply 1 decimal place here. So I'm going to add this as well. And then finally, I'm doing my addition and multiplication, right? So this here is from simply from left to right, right? Because these are all even. So these are all belong in the same category in terms of addition and subtraction. So simply go from left to right here. So 22.5 minus 6.02 would give me this here is minus, this here is 16.48 plus 0.1. I add these two numbers, I get 16.58. And this here is my correct solution for this answer. And as you can see, 16.58 here is their answer here. I like how they use bed mass as well. And they did the order of all operations correctly. So again, multiplication and division first, we're going from left to right. And then finally, we do the addition and subtraction when we're going from left to right. Solution is correct. It's a good analysis here. Okay. Let's look at 5 here. It's asking us, what is the prime factorization of 45? So I care about the prime factorization of 45. So in order for me to do this question here and talking about the prime factorization of 45, I really care about the factors of 45. I care about specifically the prime numbers here. So you can think of this 45 here, and you can think of it as a square root. Or you can think of it as a radical or something, or I'm breaking it down to specific factors here. So let me write out all the factors of 45 here first. So in order for me to divide these two numbers, or divide 45 here, what's the smallest prime number I can think of? I can think of, obviously, it's a 1. 1 is obviously always a factor, unless the value here is 0. So 1's obviously a factor. And then, so I can say 1 here is a factor. I also care about 3, right? 3 here is also a factor, right? So if I divided 45 by 3 here, I would get 3 and 15. And they actually did a prime factorization tree, which is really good. So maybe I'll do that as well. But usually this prime factorization really helps with this concept of simplifying radicals. So I'm going to do this tree as well. So I have 45 here at the top. I can break this down to 3, and then 3 times what is 45? 3 times 15 is 45. So 3 here individually is a prime factor. So I can't really break this down into more things. I could break this down into, again, 1 and 3, but this is the farthest I can break this down to. 15, I still have factors of 15, right? I know that 3 times 5 here is 15. And then finally here, because this 3 is repeated here, I don't really care. So this here is repetitive here, and obviously I break 5 to 1, or 5 into 1 and 5, right? So it means the prime factors here of 45 are these numbers here, right? I have a 1 here, I have a 3 here, and a 5 here. We don't usually count 1 as a prime factor, so we just simply say that the prime factors of 45 here are 3 and 5. And they got the solution here is correct, right? So we can say here equals 3 and 5. Or 1, 3, and 5, 3, and 5 works as well. 1 usually doesn't count as a prime factor because it's assumed that 1 is a prime factor of all numbers except 0 here. So the solution is correct. And good analysis. Okay, number 6. How much is 10 kilograms in pounds? So maybe take a moment to think about this question here. What is 10 kilograms in pounds here? And I'll give you a hint here. We're working here. kg here is kilogram. Kg here is kilogram. And this is part of the metric system. Whereas pounds here, or lb here, is in the empirical system. So we need a relationship between these two systems here because we're working in different systems. So you can say here that, and I'll give you a hint here. We have kilograms to pounds here is going to equal this value. So 1 kilogram, here's a conversion factor, equals 2.204 or 2.205 here. Or if I want to be really approximate, 2.20462 pounds here, or lb here. So it's asking us now, what is 10 kilograms in pounds? So take a moment to think about this problem here. So if I have 1 kilogram equals 2.20 pounds here, what I can do is I can say that 10 kilograms, or I can use this concept of dimensional analysis, right? I have 10 kilograms here. I'm going to multiply it by basically my conversion, right? I have here how many pounds. I want pounds to be at the top here and kilograms to be at the bottom. I have 1 kilogram, and in 1 kilogram, I have 2.20462, right? I have 2.20462. My kilograms are going to cancel out, and I'm going to get pounds left, right? So it's going to be 10 times 2.202, which is basically just if I'm simply moving the decimal place 1 to the right, right? Because I'm multiplying by 10. So this is simply just 22.0462 pounds, or you can say it's approximately 22 pounds here. So this solution here is correct. They wrote 22.046 pounds. That's perfectly fine. I use this concept of dimensional analysis. You don't have to, but I prefer dimensional analysis just because it does keep my units in check, and that I know which units cancel out, so I get the correct unit every time. So this solution here is correct. Good analysis here. Number 7. Number 7 is asking the quotient of a number decreased by 7 and -2 is 10. So this is kind of an odd question here. It's not asking me anything. So quotient, maybe it's telling me the right expression of a number decreased by 7 and -2 is -10. So when we talk about quotient here, it's something divided by something, right? So that's the definition of quotient. A quotient of a number is, and I can say let the number here be x, right? So I obviously have a variable here. So let x equals be the unknown number. And then I can say here it's being decreased by 7 and -2, right? So if it's being decreased by 7 and -2, you can also say that it's being decreased by -9, right? Because I can do simply just it's being decreased here by both these numbers here. So what I can do is I can actually simplify this this expression and say that it's being decreased by 7 and -2. So it's being decreased by simply just -9. I can add -9, or you can think of it as I'm subtracting 9 here, right? Because I know 7 plus -2 here is -7 plus -2 here would give me -9. So this entire statement here basically simplifies to -9. So basically my expression here is very, very simple now. It's just the quotient of a number here. So x is divided by something by basically -9 here equals -10. So this here is my expression for this solution here. They wrote here x divided by -2 minus 7 equals -10. This works as well, except they didn't simplify, but that's totally fine. What we can do is we can actually solve this problem, right? We can also take it a step further and solve this problem. So I can simply multiply both sides by -9, and I would get x by itself here on the left side equals -10 times -9. Just multiplying both sides by -9 here. So these two cancel out. And then x would be 90, right? -10 times -9 here. The negatives cancel out. 10 times 9 here equals 90. So this here is actually the solution to my problem. And I can say that 90 divided by 7, -2 minus 7 here equals -10. So this here is our correct solution and answer here. So this solution, I'll say solution is correct, however, incomplete. So I can say here x divided by, basically this here is -9 equals -10. And then I can say here x equals -10 times -9. So x here would equal 90 here. So I'm solving for the expression as well. So solution here is, I'll say it's correct, but they forgot to solve for the solution here. Maybe I'm just taking it a step further. Again, I don't know what the question was asking. It might be just asking where the expression. Might have been asking what it is, if it's to solve or something like that. But nonetheless, we solved the problem for them as well. So again, I've been getting a lot of these problems here. It's asking us how many quarts in a gallon, and I feel like I've answered this question so many times here. But how many quarts in a gallon? We're working on the empirical system. It's asking how many gallons in a quart, or how many quarts in a gallon. You can say that we know that 1 gallon by common knowledge equals 4 quarts, and then we can actually I'll also rewrite the other units where 1 quart equals 2 pints, 1 pint equals 2 cups. But the question is asking how many quarts in a gallon, right? So this first statement will give us our answer, right? 1 gallon here equals 4 quarts. So therefore, there are 4 quarts in a gallon, right? Therefore, 4 quarts in a gallon here. So the solution here is correct. There are 4 quarts in a gallon. Good analysis. All right, number 9. It's asking a question about corresponding angles theorem. maybe it's asking what is corresponding angles theorem, or define corresponding angles theorem. They didn't really ask a question here. Corresponding angle theorem. And then they, again, with geometry questions here, they actually they drew a kind of a line here. They drew a visual for us to kind of figure this out, which is perfect. So what is corresponding angles theorem? Well, you have here, this here kind of gives you the solution here, right? So it says corresponding here angles are the angles that are formed in matching corners or corresponding corners with traversal, when two parallel lines are crossed by some other line. So let me redraw this for you, and I'll explain what that is in common terms here. So if I have two parallel lines, which means they have the same slopes and they never intersect, if I have one line that intersects both of these lines here, I'm going to create angles, right? I have angle, basically, this here is angle A, or angle 1 in the image here. Angle 1, this is angle 2, angle 3, angle 4. This here would be angle 5, angle 6, angle 7, angle 8, right? And corresponding theorem basically just states that these here, these angles here, so specifically, let me erase these guys here just to make this a bit nicer. So I have here angle 1 and angle 5 are going to be the same angles, right? These guys here are corresponding angles. Angle 1 here and angle 5 here, therefore, are the same angles. So we can say that 1 and 5 are the same angles. 2 and 6 are the same angles. This here is 3 and 7 are the angles, and 4 and 8 here. 4 and 8 here are the exact same angles as well. So these angles are equal to each other. So if I say that, so let me redo a problem. So let me erase this stuff. And if I say that, so pen works here. There we go. If I say that I have an angle, let's assume that this here is, or maybe let's assume this angle here. Let's assume this angle here is 60 degrees. What would be the result of this angle or this angle? And this is just an extension. This is the problem here. So due to corresponding, and according to corresponding angle theorem, remember this here was angle 2 I defined, and 2 here equals angle 6. These are on the same side of the angles here, right? So therefore, this angle must also be 60 degrees here. And how would you solve for this angle here? Well, I know that, again, this here is a straight line here, right? Straight line here. And this entire angle, so let me do this in blue here. This entire angle here has to equal, or in this guy here, has to equal 180 degrees, right? Because I know that this here is 180 degrees. So therefore, I can say that if I want to solve for angle 1 here, or angle 5 here, I can simply just do angle 1, or and angle 5 here, because their corresponding angles equals 180 degrees minus 60 degrees, right? And this here would equal 120. So therefore, my angles on angle A and angle 1 and angle 5, sorry, are 120 degrees. This here is also 120 degrees here. So it's just saying the corresponding theorem basically just means that I have pairs of angles are always the same if I have two parallel lines that are intersected with a traversal. So the solution is correct. Good analysis here. I think I have 2 more questions for this section here, and I might be able to jump into the calculus question that I kind of was working on before. But we'll see how, what if time permits us here. So it's asking which value is equal to 5% of 1500. Value is equal to 5% of 1500. So let's take a moment to think about this problem here, and we will take it up together. Again, we're given a percentage here, and we want to convert it into a fraction or a decimal for us to solve for this problem here. So it says here, which value is 5% is equal to 5% of 1500. Again, I can always convert this percentage into a decimal or a fraction to fraction or decimal. And again, if you're not given a calculator on these assignments here, you would probably pick the fraction example here. So if I'm converting a percentage into a fraction, get 5% towards a fraction here, again, I simply have to divide by 100, right? So I can simply say times 1 over 100. This here would be 5 over 100 here. And this here is my fraction form of the percentage 5%. And what I could do is I can now take 5 over 100. I'm going to multiply that by 1500 to solve for what the value is equal to 5% of 1500, right? So I can say that I can basically I can put this over 1 here. I can say that 100 here cancels out, and I can divide 1500 by 100, which would be 15, right? So, and then I have to do 5 times 15 here. 5 times 15 is 75, divided by 1, right? Which is simply just 75 here. So this solution is correct. Again, therefore, 5% of 1500 is equal to 75. Again, I got 75 as well. So the solution is correct. Good analysis here. And then finally, for question 11, we have another conversion question or measurement question here. And I believe we have enough time to solve for to pick off where we left off with the calculus question. So that's awesome. So how many cups are in half gallon? So again, we have these conversions here, right? 1 gallon here equals 4 quarts. And again, we're working in the imperial system, right? So these both units are in the empirical system. And then 1 quart equals 2 pints. Finally, 1 pint here equals 2 cups. So if I want to convert this from cups to half a gallon, what I'm going to have to do is I'm going to start with half a gallon, right? So I have here, I can write here half a gallon. Half a gallon. I need to change from gallons to quarts first, and then from quarts to pints, and then from pints to cups, right? So if I want to convert gallons to quarts first, simply I'm going to have to do, I know that 1 gallon here, going to cross out my gallons, equals 4 quarts, right? So it equals 4 quarts. And if I want to convert quarts to pints, I know that here 1 quart equals 2 pints. And then finally, how many pints in a cup? Obviously, in 2 cups, there is 1 pint, right? So 1 pint is 2 cups here. So if I multiply this through, I'm going to get how many cups are in half a gallon. And as you can see, my units are going to cancel out. Gallons cancel out here, quarts cancel out, and pints here cancel out. So therefore, I'm only left with here. I'm left with cups here, right? So if I multiply half by 4 here, that's going to give me 2. So I have 2 times 2 pints times 2 cups, right? 2 times 2 is 4, times 2 equals 8. So I have 8 cups. So therefore, there are 8 cups in half a gallon. And this here is my solution. And as you can see, there are 8 cups in 0.5 gallons here. They didn't really show their work though. So I'm going to say solution is correct, but work was not shown. And then I'm going to write maybe 0.5 gallons here multiplied by 4 quarts over 1 gallon multiplied by 2 pints over 1 quart multiplied by 2 cups over 1 pint would equal 8 cups here. So this here ends the grade 11, or sorry, grade 9, grade 9 and grade 10 kind of math here. It's mostly just pre-algebra, algebra 1, and geometry questions. So I'm going to bring up the calculus question that I was working on yesterday, or 2 days ago now, and that and then we'll talk about that. So let me just bring this up, and let me just start the other stream for you as well. Let's see here. Yeah. I believe it was this question that we kind of ended off last stream with. So I'm going to redo this problem for you because I messed up the previous question. When working with the solution first, I realized that there was an image that I could see here that I didn't click on. So let me just work on this problem here, and maybe we'll finish off this video here because this is a very, very long question. So again, what we have here is an optimization question in calculus. And it's asking us, a normal window has a shape of a rectangle with a semicircle on top. Let me see the diagram, and I know how to draw the diagram this time here. If the perimeter of the window is 30 feet, find the dimensions of the window with the greatest possible area. Round your answers to 1 decimal place. So if we have a Norman window here, and it's asking us, a Norman window has a shape of a rectangle. There's a rectangle here with a semicircle on top here. And if I have here, the perimeter here equals... So P here equals 30 feet. And it says find the dimensions of the window with the greatest possible area. So I'm going to assume that this here is my X value. This here is my Y value. And again, this guy here, or let me redraw this. This guy here is actually a dashed line, right? Because again, normal window, this isn't like a straight cut here. It's simply just a semicircle on top. And this here, I'm going to call this between this point to this point here. This is going to be my radius, so my R here. So I need to find some type of formula to figure out first the perimeter and to figure out the dimensions. Right? So I have to use this concept of area and perimeter to figure out what the dimensions of this are. So if I want to do that, let's do perimeter first. So P here would equal, I have 30 feet, so I can set this to 30 feet here. So let me just set this already to 30 feet. Equals perimeter of basically it would equal 2 parts, right? I have a perimeter, I need the perimeter of my rectangle part and the perimeter of my semicircle here. So if I have 30 equals perimeter of my rectangle, what is the formula? Well, I know it's 2 times length times width, right? Or X times Y here. So this here is my perimeter of my rectangle plus what is the perimeter of my semicircle? So this is where it gets tricky, right? So pretend I have a semicircle here. I have here, or let me pretend I have a full circle actually. Full circle might be a lot easier. This is just a side note here. But in a circle, if I want to find the perimeter of the circle, it's simply the same thing as saying the circumference of a circle. And circumference of a circle, I know here is 2 pi r, right? The circumference of a circle, or you can say it's pi d, right? But we want things in terms of radius, so I'm going to use 2 pi r as our formula here. So 2 pi r equals circumference. Well, if I have semicircle, if I split this in half, what is my circumference then? So obviously my circumference is halved, right? So which equals simply just pi r, right? So which means therefore my semicircle here equals simply just pi r. So you can say here this equals pi times r. I'm going to erase this just to make some room here. But now we have to think about, okay, we have a lot of variables here with x, y, and we have r, right? Well, we have to think about, is there a relationship between x, y, and r? And there is, right? If you think about this this problem here, the distance between here to here, here to here is simply just half, right? If I have half the length, right? If I have, again, this normal window here, from here to here, is simply just half the distance between from here to here, right? And this might be better illustrated if I were to kind of download this image here. So just give me a second. I can download this image for you. And you can see that this R here is, again, you have 2R here. So you have 2R. I used X here, but R here is half this value, right? This radius is half the value of this this length here. So I'm going to assume that this here, this R, I can change this into half of X, right? This is simply just half of X. So that means I can change my R here to become half of X, right? Or I can say, I can actually rewrite this as half pi times x here. And now we have a solution here that is a bit more credible, right? A solution here that only has two unknowns here. So if I were to simplify this out, I would have 30 equals, I can multiply 2 with distributive property, so 2x plus 2y plus half pi x here. And this here is our first kind of our first perimeter basically formula here. And what I could do with these guys is I can actually isolate for, I'm going to isolate for y. And why I'm going to do that is because I'm going to create another formula for area, and we're going to actually have to optimize the area, because again, I care about finding the dimensions of the window with the greatest possible area, right? And again, with the area, I'm going to have two unknowns as well. So therefore, I'm going to require a substitution for me to get rid of a variable. So I'm going to simply do that step now. So I have 30, I'm going to bring 2x to the other side here. So I'm subtracting 2x from both sides, plus half pi x. I'm going to, again, bring half pi x to the other side as well. So I have 30 minus 2x minus half pi x equals 2y. And then I can simply divide everything by 2 here, right? If I divide everything by 2 here, y would equal 30 minus 2x minus half pi x divided by 2 here. And this here would be my algebraic expression for y. And you can kind of simplify this as well. You can say 30 divided by 2 here is 15. Negative 2 divided by 2 here is negative 1, so simply just negative x. And negative half divided by 2 here would be negative 1/4, right? So I'm just simply putting 1/4 pi times x here. So this here is my simplified form of our y here. So this here is an important equation, and we'll come back to this as well. So we've isolated for y here. Now we have to figure out a formula for x, or for area, right? Because that's what we care about, the dimensions with the greatest possible area. So area. So we want area of the total shape, right? So if we want to calculate area of the total shape, again, I have this Norman window here. I have a rectangle and a semicircle. So I care about the area of the rectangle plus the area of the semicircle, right? So area of the rectangle plus the area of a semicircle. And this is, you can say it's area total or total area. But area of rectangle, I know it's length times width. So it's basically just x times y plus area of a semicircle. So again, this here gets a little bit tricky. What is area of a semicircle? So again, if I were to draw out a circle here, this is again, this is not a semicircle, but it's just a full circle here. The area of a circle is pi r squared, right? So therefore, if I cut this in half, what is the area of a semicircle? Well, area is just simply half, right? So this would be half pi r squared. So the area of a semicircle here is half pi r squared. So right here, half pi r squared. And then I know my relationship between x and r, right? X and r here. So r here, I know that it is half of x, right? As you can see, it's half of x here. So I can input simply, this guy here would be half of x squared, right? I'm just simply making r here equals half of x, right? I can kind of clean this up first before I do the derivative. So a equals x times y plus half pi, half of pi, and then I have half x squared. Half x squared is simply just, I can rewrite this as half x times half x. So this here is simply just half pi. Half x times half x is 1/4 x squared, right? Half times half is 1/4. X times x is x squared. And then I can clean this up by saying x times y plus half times a quarter here is 1/8, and then pi x squared. So this here is my area formula. As you can see, I have two variables here, and what I'm going to do is I'm going to do a substitution, right? I have my y here already. I'm going to substitute my y in for this y, so I have everything in terms of x here. So let me just do a substitution. So I'm going to say here, sub y equal substitute y for y here. So I'm going to say here, a here equals x times y here, which is this 15 minus x minus 1/4 pi. So 15 minus x minus 1/4 pi x. And then I'm going to add it plus 1/8 pi x squared. And I can clean this up here by using distributive property. Again, x times 15 here is 15x. X times negative x is negative x squared. And then simply this here would be 1/4 pi x squared plus 1/8 pi x squared. I can take now my these two terms are very, very similar, so I'm going to combine those terms as well. I have 15x minus x squared, and then I have minus 1/4 plus 1/8, right? So minus 1/4 plus 1/8 would be negative 1/8, right? So again, you can think of it as negative 2/8 plus 1/8 here is negative 1/8 pi x squared. So this here now becomes very, 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 very easy, right? I have this kind of a quadratic equation here. What I can do here is I can take the derivative, right? If I want to take the derivative and I want to set it to 0 to basically care about the maximum, right? So I have a prime here. This will equal, take the derivative of this guy here, 15x becomes 15, minus, I bring the 2 down here, so it's simply just 2x, minus, I bring the 2 down here, 2 times 1/8 here is 1/4 pi times x here. I'm going to set this to 0 to figure out my the maximum here, right? So set this to 0 here to figure out what x is. 15 minus 2x minus 1/4 pi x. I bring 15 to the other side, which makes it negative 15 equals negative 2x minus 1/4 pi x. And then here, I could break this down to, I could basically combine these two terms here. So 15 here equals negative 2x. Or I could factor out the x here, actually. Let me factor out the x first. I'll factor out the x here. I get negative 2 minus 1/4 pi. Or I can say it's pi over 4, right? Or pi over 4 here. And then I simply have to divide both sides by negative 2 minus pi over 4 to get x, right? So x here would equal negative 15 all over negative 2 minus pi over 4. And you could plug this into your calculator if you wanted to, and you would get something like, you should get a value that looks like, let me make sure I'm in degrees here, 5.38 here. So this here, x here would be 5.38, or you can round this to 5.4, right? I want it to be one decimal place here. So 5.4, that's my x value here. And what I can do, once I have my x value, I can easily solve for my y value here using basically any of these equations here. So I would use, again, this equation here. So if x here equals, I'm going to take more decimal places here, and then I'll round as my as the final answer here. But I'm going to rewrite this y equation here to give me some more real estate here. So y there we go. Y here equals 15 minus x minus 1/4 pi times x. Well, I know that y here equals 15 minus x here is 5.385 minus 1/4 pi times 5.385. You can simply throw this all into your calculator and you would get an answer of, let me just type this out, 15 minus 5.385 minus 1/4 times pi times 5.385. This here would equal 5.385. 386 technically. So this here would equal, y here would equal this number here. And this number makes sense, right? So again, but both my, my dimensions here are x here is 5.4 and my y here is also 5.4. So I can say that dimensions of window to maximize area are, and I can say it's 5 by 5, 5.4 by 5.4 feet. And this is in feet, sorry. Feet by 5.4 feet. And this makes sense, right? If I want to maximize the area, obviously, my length and width have to be very, very, very similar, right? Because again, the maximum area of a rectangle would be a square, right? So this here makes sense. So this here is my solution for this problem. And again, I think they have an incomplete solution here. So I'm going to write here just incomplete solution. And I'm going to see if I can type this out. So basically I'm setting, or maybe I won't show, I don't know if I can show my work, or I can take a screenshot maybe and maybe upload this, but I don't think I can. So maybe I'll just do, it looks very daunting, but it really isn't. We basically need to find formula for perimeter of shape. So this here would P equals 2 times x plus y plus half of pi, half times pi times times x here. And then find formula for, and then I'm going to basically say rearrange for y. So therefore y here equals, I have 15 minus x minus 0.25 pi x. And then I'm going to say find formula for area of shape. So a here would have been x times y plus 1 over 8th pi x squared. And then find the derivative, or substitute, sorry, I'm going to substitute y into area equation. So a would now equal 15x minus x squared minus 1/8 pi x squared, and then find derivative of area equation. So this here would be a prime equals 15 minus 2x minus 1/4 pi x. I'm going to set derivative to 0 and solve for x. So I have basically 0 equals 15 minus 2x minus 1/4 pi x. Therefore, x would equal 5.4. Substitute x value into y equation to solve for y. Y would also be 5.4. Therefore, dimensions of the shape to maximize area would be 5.4 feet by 5.4 feet. So this solution is incorrect because this is an incomplete solution. So sorry about cutting off the video last session on Monday, but I didn't get to finish the problem here. So this here is a finished problem. Again, my solution here is 5.4 times 5 point here. So this is probably a very, very challenging optimization problem. Just because you have irregular shapes, you also have to use algebra to isolate for something, and you also have to find the derivative and set it to 0. So it's honestly encompassing a lot of things: geometry, algebra, and also calculus as well. So thank you so much for watching this video. Again, if you like this video, what I'm doing here on OneClass, you can definitely subscribe to the YouTube channel at youtube.com/OneClass, and you can find more videos there. This obviously video will be recorded, so you can it'll be uploaded, so you can kind of play back to your own speed. As always, thank you so much for watching. I'm going to be streaming about an hour from now at noon, so you can stay tuned for that. So as always, thanks for tuning in. Stay safe, stay healthy. Have a great day. Cheers.